Suppose you're given a task that you have to find statistically extreme points. In other words, you have to find outlier. And these are your points right here. So, can you find that point? Well, by just looking at the numbers, it's hard to tell. How about this one right here? I tell you, you have this group of people over here, and you have to find an extreme point. You have to find a person over here that does not belong here. Well, that's easy. You can just look at this guy and you can say, okay, that's the guy, that's an outlier. So, this is your outlier right here. So, what exactly is an outlier? Well, outliers, they are your data points that significantly deviate from the average or typical values within your data set. So, let's say this is your age right here, right here. And you can see that most of the people, their age is between 40 and 60. Okay, so each one of these crosses, these are your data points. So these are your ages of people. And then you have one guy whose age is 90 right here. So this is an outlier. Then you have another guy whose age is 10. This is an outlier. Let's look at this one. Here you have age and income. So as age increases, people income increases. So you can see most of your data point is spread over here, right? And then you have one point, this right here. This is not part of this group. So this is an outlier. Same thing with this guy. This is an outlier. This is not part of this cluster. So why do they happen? Well, they can happen due to measurement errors, due to experimental anomalies, or maybe because of truly exceptional observation. For example, let's take a look at an example of a truly exceptional observation. In this particular instance, it's possible maybe this kid right here, this is a young kid, his age is only 20, and maybe he's making more money, his income is very high than the rest because he has an higher education. On the other hand, this guy right here, maybe in this particular instance, this guy is an older guy, but maybe he does not have enough experience. That's why his income is low. Well, there are a few problems with outliers. The number one is the mean right here. So suppose these are your data points 3, 3, 4, 5, 5, 7. You calculate the mean of this, and the answer comes out to be 4.5. All right. Now let's say this 7, I change it to 70. And because I changed this number to 70, now your average, your mean value, because of this 70, it increases. It actually becomes 15. So you see that your average went from 4.5 to 15 because of the presence of the outlier. So it changed your mean drastically. On the other hand, your medians, they are not affected by the presence of outliers. So let's say this is your data without the outlier. In this case, my median would be middle, the average of the middle, and the answer is 4.5. Well, when you have an outlier, in this case is 70, all right, and you can see that your average of the middle number is still going to be 4.5. So median in this case did not change. So medians are not affected by the presence of outliers. So one of the method that we can use to detect outliers is IQR. IQR stands for interquartile range. So suppose you have this data right here. You have student names, and let's say this is a score. This could be age, this could be income, this could be any number. This number is exactly the same that I started this session with. So this is the data that's given to you, and this I'm extending this data over here and all the way over here because my screen is not able to accommodate all the data. So suppose you have to find the outlier in this data right here. So the first thing you do, you order your data set. That's your step one. So this is my actual data set, 52, 48, 45. This is my data set right here for that particular column. And then I ordered this data set. Now it's ordered. You can see that 28, 31, all the way up to 74, 75. That's your step one. And then step two, you find your Q1, Q3, and IQR. And the way you find your Q1, you split your data into two halves. So you have upper half right here, and this is your lower half. Find the median of your upper half. So the median of your upper half would be 44 in this particular instance, and the median of your lower half would be 52. So this is my Q1, and this one is my Q3. And by the way, this right here, the median of the whole data set, that is referred to as Q2. That's your median of your whole data set. And then you find your IQR. IQR formula is Q3 minus Q1. IQR basically is the distance between Q1 and Q3. So in this case, the answer will come out to be 8. On a side note, your Q1, Q2, Q3, essentially they refers to your quartile. So Q1 means that it is a data point where 25% of your data falls below that Q1. Q2 is the data point, or is the data point where 50% of your data it falls below Q2. In other words, 25% of your data falls between Q1 and Q2, and likewise your Q3 is a data point where 75% of your data it falls below Q3. Or you can also say 25% of your data falls between Q2 and Q3. And so this is the physical significance of your Q1, Q2, Q3. Okay, so sometimes you'll see this box plot right here. So in box plot, this would be your Q1, this will be your Q2, and this will be your Q3. And your IQR would be the distance between Q1 and Q3. And then step number three, now you identify your lower and upper bound. So the formula for lower bound is Q1 minus 1.5 times IQR. In other words, let's say this is your box plot. This would be my lower bound. So this lower bound would be this value minus this particular distance right here. And that will give me this right here. So this will be my lower bound. Okay, and this is how you calculate my lower bound, Q1 minus 1.5 times IQR, and the answer comes out to be 32. Likewise, your upper bound would be equal to Q3, that would be equal to this plus this distance. So in this case, it is 1.5 times IQR, and the answer comes out to be 64. So this is my lower bound, and this is my upper bound right here. Step number four, so the points that fall outside the lower and upper bounds, these are your outliers. So this is my original data set right here. And now you can identify your outliers. My lower bound is 32. That would be somewhere over here. And my upper bound is 64. That would be something over here. So all the points that are on this side and all the points that are on this side, these are my outliers. That would be this and this right here. So 28, 31, 68, 74, 75. These are my outliers. These values, they represent statistically extreme points in your data set. So the final result is this. In my order data set, these are your outlier points, these ones right here. If I put these numbers on a number line right here, so you can see that all my data is right here, but then you have these points, this one 68, 74, 75, these points, they're kind of like extreme. And likewise 28, 31, that would be these 2 points right here. These are my extreme points. Sometimes you can also see something like this in a box plot. So this is a box plot. So this is my Q1, that was 44. My Q2 was 48 and my Q3 was 52. So this is my Q1, Q2, Q3, and any value that falls on this side or this side, these are my outliers. This would be my lower bound or minimum value, and this would be my upper bound or maximum value. Sometime in the literature, you may see a box plot that could be horizontal, or sometimes you may see a vertical. They both essentially carry the same information. So in this case, this is my horizontal right here, and this right here, this whisker, this is my minimum point, and any data that falls on this side, this will be my outliers, and likewise, any point that falls on this side, that will be my outliers. So in this case, that will be my Q1, Q2, Q3, and this will be my IQR. This is for horizontal. For vertical, you're going to see IQR like this, and this will be your maximum on the top, and your minimum would be at the bottom right here. So now I'm going to show you how you can detect outliers using IQR method. So first I'm importing my pandas as PD, and I'm reading the CSV file, and then I'm printing the data frame. So when I run this, it's going to print out the data frame, and there are a total of 45 records. You can see that it starts with 0 all the way to 44 at the bottom. So there are 45 records, and these are like name and score. So these are the corresponding scores for each one of the students. And among these scores, there is someone over here. There are some values that are outlier values. So let's determine that. In order to find your IQR, you need to know your Q1 and Q3. Your Q1 refers to your 25th percentile. And the way you do that, the way you find that out is using this inbuilt method called quantile. And you specify your parameter 0.25. That's going to give you your Q1. Likewise, you can find your Q3 with your parameter 0.75. That's going to be your 75th percentile for the score column. And then after that, I find my IQR. IQR is going to be Q3 minus Q1. Also, at the end, I'm printing my Q1 and Q3 and also IQR just to see what my values are. In this case, my Q1 is 44 and my Q3 is 52, and my IQR comes out to be 8.0. That's the difference between 52 and 44. Then we define our lower and upper bound. So my lower bound is going to be Q1 minus 1.5 times IQR. That's going to be my minimum value. That any value that's below this, that's will be my IQ. Those would be my outliers. Then I'm defining my upper bound. Upper bound was Q3 plus 1.5 times IQR. Then I'm printing my lower bound and upper bound just to see what my lower and upper bound are going to be. So this is my lower bound and upper bound. So any value that is outside this range, that is any value that is below 32, that's an outlier. Any value that is higher than 64, that is my outlier. Any value that is in between, any score that is between 32 and 64, those are regular values. Those are not outliers. So in this case, let's print out my outlier. So first thing I'm doing, I'm creating a condition. So the technical word for that is mask. So in this case, I'm creating a filter. So I'm saying any values in my column score is smaller than lower bound. Okay, you actually filter that out, or you can also filter out any score values in my data frame that is greater than upper bound. So this is my filter right here. So this is my mask, and put your mask inside your data frame. And this would be my outlier. So when I run this, it's going to print out my outliers, and you can see that these are my values who are outliers: 28, 31, 68, 74, sorry, 75, and 74. So there are many methods to deal with outliers. One of the common method is a trimming. In this case, basically all you do is remove the outliers. It's as simple as that. So in this case, I'm creating a mask. This is my filter right here. And I'm saying that any score that is greater than or equal to lower bound, and any score that is smaller than or equal to upper bound. Okay, this is my filter. I'm taking all that data and I'm putting this mask, I'm putting this filter inside my data frame right here. And this will return me a data frame trimmed. So this is my new data frame. This one actually contains no outlier, and I'm printing this data frame. And now this one contains no outlier. You can see that this actually goes with 0 all the way up to 39, and there's only 40 records. That means so there were, if we start with 5 records, I mean 45, and now we are left with only 40 records. So those 5 data points, those were outliers. They have been trimmed. They have been removed. Another common method that is used to deal with outliers is called capping or winsorization. So let's print out my lower and upper bound. So when I run this and it prints out my lower and upper bound, also I'm printing out my outlier. So this is my lower bound and this is my upper bound. These are my outliers. So in capping or winsorization, essentially what I do, I take these scores, I take these values, and any value that is smaller than 32, I cap them to 32. So these values, you see that 28 and 31, these are smaller than 32. So these numbers, they're going to turn into 32. And so instead of deleting them, I'm resetting them to 32, these two. This one, 68, 75, 74. These values are bigger than 64. I'm going to reset them. I'm going to change them to 64. So this is called capping. So I accomplished that using this particular logic over here. So I'm creating a copy of my data frame. I'm calling it df winsorized. And then in this case, I'm calling the column score. Inside the column score, I'm clipping the value. I'm saying that any value that is smaller than lower bound, any value that is higher than upper bound, clip them. Okay, just take them, reset them to these values like the way I just explained over here. And then I print my df winsorized. And you can see that your values now are clipped. So if you go back over here, you can see the Harsh, Ria, Naveen, Pankaj, these values have been clipped to these numbers right here: 32, 32, 64, 64, 64. These were your outliers. If you go back over here, you can see that these were your original outliers. Now they're clipped to these numbers: 32, 64.